Okay, good evening, gentlemen and ladies. Yeah, you're welcome to tonight class. How was your day? Hope it was fine. Okay, yeah. Tonight we'll continue from where we stopped. Please try and invite others. Try and invite others. Is that clear? Just try and invite others. Okay, so let us start our class. Yeah, our last class on Saturday, we looked at implicit functions. We solved one or two examples, if I'm not mistaken. So I want to start from where we stopped. Then after this, we'll look at parametric functions tonight. Amen. It's okay. So let's look at my example here. I think the other day we consider. Let's look at this example. Find y prime if we have x square y plus y square equals to 10. Hope you are seeing the board. Okay. So far, so good. So let's try and do something. Please invite others. Share the link. It's okay. So far, so good. So now we are asked to differentiate this implicit function. So we write solution. Our x square y plus y square equals to 10. So what next? We now write d all over dx, open bracket, x square y plus d all over dx, open bracket, y square equals to 10. Amen. So what we need to do here, as you can recall, here we have two functions, two of us. So we use a product rule, but we can differentiate it straight, direct. Is that clear? So here we differentiate s squared then whole y. So if we differentiate s squared, we are supposed to have 2x. Then easy to multiply y. We are going to have 2xy, the what? The x, right? Because we differentiated for x all over the x. Then since we are talking about two functions, it's going to be product rule. So here will be plus, we hold x squared and differentiate y. If we differentiate y, we are going to have 1. True or false? Yeah. So 1 times x squared, we'll have x squared. So x squared d what? dy all over the x, because we differentiated for y. That is why we are having the y. Then differentiate y squared, we are going to have plus okay, sorry, we did not put d all over the x here, but we know that this is a constant already 0. It's not even necessary. So here, if we differentiate y squared, we have 2y dy all over the x, which is what? Equals to, differentiate the constant, 10, equals to what? Equals to 0. Amen? Equals to 0. Any question, please ask. If you have any question, ask. Do you have any question? I expect the number to be more than this. It's only 37 of you that are here, active here. Please try and invite others. Okay, so can we proceed, yes or no? Or we can proceed, right? It's okay. So if you agree with me, so let's proceed further. So you don't need a prophet to tell you. Love you guys. Yeah. You don't need a prophet to tell you this and this will go. Here will be 2xy plus x squared dy all over dx plus 2y dy all over dx equals to 0. So this and this, they are like terms. So we now move this to the right hand side. So when this one crosses the sign of this equality, it becomes negative. So here will be x squared dy all over dx plus 2y dy all over dx is equals to minus 2xy. Amen. So look at the left hand side. What is common? If you can see what I am saying here, dy all over dx is common, so factor it out. Dy all over dx is common, so x squared plus 2y equals to minus 2xy. Amen. Yeah. So what next? For us to obtain dy all over dx, we divide through by this. So if we divide through by this, our dy all over dx now be equals to minus 2xy all over x squared plus 2y. Yeah. So this is how you are supposed to differentiate this function. As you can see now, this is the final answer. Any question? Do you have any question, gentlemen and ladies? Godwin, Your Honor, he said I should, is it Umar, Usman, come again? Okay, Samaila, it's okay. What I'm trying to say here is nothing but the truth. These are implicit functions. So we are going to differentiate this function implicitly. So how? By approaching it this way. As long as you know how to differentiate a given function, I don't think this will give you a problem. So here we have x squared y, then we have y squared, then equals to 10. Note that 10 is a constant, and whenever you differentiate a constant, it is always 0, true or false. Okay, so when you differentiate two functions, we have x and y here. By right, you are supposed to use product rule, true or false. But it's not necessary here. We can differentiate it direct. So what I did here is I try to hold this one constant. Look at it here, x squared y. So hold this one constant. Whatever answer after differentiating x squared, you have used to multiply what is here. So if you differentiate x squared, you are supposed to have 2x. So what is there? Y. So it's going to be times y. So this will going to give you 2xy. True or false? Do you agree with me? And that is why we got 2xy dx. This dx means you differentiated for what? X all over the x, the original dx. Then plus, you now hold x squared constant, then differentiate y. All of you know that if you differentiate y, this is how it will be. 1 times y raised to the power of 1 minus 1, true or false? And 1 times y raised to the power, 1 minus 1, is it not 0? So anything raised to the power 0, is it not 1? So 1 times 1, what are you supposed to get? Have, rather. You're supposed to have 1. So use the 1 to multiply what is there, x squared. That is why we have x squared dy. Dy means you differentiated for y all over the existing dx. Then plus, we differentiate this one. When you differentiate y squared, you are going to have 2y dy all over the x equals to, if you differentiate a constant, you are supposed to have 0. True or false? So that is why you are saying the 0 here. Yeah. Do you understand, gentlemen and ladies? Hope you are following. Okay. So, Usman, hope you are following. So now, what did there is after this and this can divide to give us 1. So by the time we use 1 to multiply 2xy, is the same as 2xy plus x squared dy all over dx plus 2y dy all over dx squared equals to 0. So now what I did, listen, we take this 2xy to this right hand side. So this crosses the sign of equality becomes what? Minus 2xy. That is why you are saying, so you can now see that remainder this and this. That is what you are saying on the left hand side. Then here, when you look at this and this, something is common. Ask yourself, what is common? Dy all over the x. So you factor it out. Then you put x squared and 2y into the bracket because we are asked to find dy all over the x. So at this point, you divide through by x squared plus 2y. Then this is what you are supposed to get. Any question, please? Do you understand? Those of you that are just coming. Do you understand? Any question? Yes or no? Or I should continue? I should continue, right? It's okay. So let me continue. So let's move further to consider more examples. At least I have other examples here. Okay. One of the examples here is okay, x another example I'm going to consider. Let's consider another example. X squared y minus xy squared plus x plus y squared equals to 0. I said find y prime. Okay, it's simple as ABC. everybody should look at the board. Take note of this question. Take note of this question. Take note of this question, please. Okay, so let's look at this problem. Let's look at it together. So what we need to do, we write solution. Okay. Our x square y minus x y square plus x plus y square is equals to 0. So far so good. So here will be d all over dx, all in bracket x square y minus d all over dx, all in bracket x y square plus d all over dx, all in bracket x plus d all over dx, all in bracket y equals to what? 0. Do you agree with me? So let's differentiate this. We hold y, differentiate x squared. We are going to have 2x multiplied by y. We have 2x y dy all over dx. Then plus whole y x squared, whole x squared. Then differentiate y. To differentiate y, you have 1, 2 of us. If you multiply x squared, you have x squared dy all over dx. Now what do we have here? Minus. So whole y squared differentiate x is 1. Use it to multiply y squared. We are going to have minus y, because here is minus y squared dx all over what? Dx. Then since here is minus, we'll be making use of the minus sign. Supposing it's plus, just be adding plus. So minus whole x, then differentiate y squared, going to give you 2y times x, 2xy dy all over dx. Then if you differentiate x is 1, so 1 times dx is the same thing as plus dx all over dx. Then differentiate y is 1, then plus dy all over dx equals to 0. Do you agree with me? Please look at the board. Equals to 0. You agree with me, right? Okay, so it means here you don't need the prophets to tell you, oh, this is sorry, it's supposed to be x. That's what differentiated from. So this and this will go. This and this will go. 2 of us. This and this will go. So here will be 2xy plus x squared dy all over dx minus y squared minus 2xy dy all over dx. Then plus here is 1. 2 of us. It is not 0. Please take note. Then plus dy all over dx equals to what? 0, right? Okay. So what do? We collect like terms. So when we collect like terms, this, and this are like terms. It's going to be x squared dy all over dx, amen. Then minus 2xy dy all over dx, then plus dy all over dx, plus 2xy minus y square plus 1, then equals to 0. Amen. Hope you are following. Look at the board, please. Are you following? Hope you are following. Oh, y square. We are right now. Look at it now. When we differentiated for x, we are going to have 1. We use to multiply y square. Look at it here now. So we are right. Yeah, we are right. Is that clear? Okay. Excuse me. If you can see what I am saying, we have to take this to the right hand side. So here will be x squared dy all over dx minus 2xy dy all over dx plus dy all over dx equals to, let's start with this, minus y squared crossing the sign of equality becomes plus y squared. So here will be plus 2xy crossing the sign of equality becomes minus 2x y, then my plus 1 crosses minus what? 1. Do you agree with me? Minus 1 minus 1. Hope I'm right. 2y 2x square. Hope am I right? Okay. Yeah. Okay, this will give us this. Then here will give us this, two of us. Then here, the same here, we're going to give us this. Then here we're going to give us this. Okay. X square, y square. It's okay, we are right. Then here we're going to give us this. So, at this point, what is common here? We factor out dy all over dx, open bracket, x square minus 2xy plus 1 equals to y square minus 2xy minus 1. Amen. Look at the board, please. Look at the board. Hope you are following. Hope you are following. Okay, so now what we are going to do here is for us to divide through by this. So if we divide through by this, is what we are supposed to have. So therefore, dy all over the x now equals to y square minus 2xy minus 1 all over x square minus 2xy plus 1. Amen. This is our final answer. Please, any question? There's any question? You ask if there's any question before we proceed further. If you have any question, please ask. Yeah, any question? Okay, Moses, can they ask your question? You don't understand where? I think your network is bad. It is your network where you are. Here is clear. The last y is squared. Yeah, the last y is squared. Okay. Oh, yeah. Okay, yeah. Somebody corrected our solving. The last y is squared. Yeah. I think, who is that person? Sunday. Sunday, I'm owing you half mark. Please remind me in class. Sunday, thanks for reminding me. Yeah, the last here is supposed to be, okay, y square. So if here is supposed to be y square, but we solve it, so it means we are going to leave it like this. Yeah, let's leave it like this. If we leave it like this, this is how you are supposed to solve it. But if it is y square, even x2 is squared. I forgot to put the square here and here. So you can leave it like this, no problem. You can solve it. This is how you are supposed to have the answer. This is how you are supposed to solve it. Is that clear? Is that clear? It's okay. So let's proceed to consider my example. Okay. Let us proceed to consider my example. Okay. Yeah. So let's look at given x raised to the power of 3 y plus x y raised to the power of 3 equals to 2. We say find dy over the x at the points at the point 1, 1. As simple as ABC. Is that clear? Please look at the board very well. Listen attentively. It will do you good. It will do you good. Those of you that are just coming, I think with this example that we are about to solve, it will do you good. Just listen. Is that clear? You are welcome. Okay. So look at it. I want to consider this problem. So what we do, write solution of d all over dx, open bracket x cubed y plus d all over dx, open bracket xy cubed, right, equals to d all over the x, open bracket 2, right? Already here is what? But this one, we said we should find the value of the x at the point x comma what? This is a two coordinates point. So you know that when we have a two coordinate, we have x comma what? Y. Two coordinate system. So it means this is equals to the given points are 1, 1, true or false. So it means our x is what? X is 1 and y is what? Sorry, y is also 1. But what if, assuming you have been given the points -1, 2, you don't need a prophet to tell you true or false. It means your x is equals to -1 and the y is equals to what is here? 2. So take note. But before we make use of this, we have to differentiate it first so that we can find the gradient. It's okay. So far, so good. So let us differentiate this. Note that we have two functions here. This is x and this is y. So the same thing applicable. Take note. So if we differentiate x cubed, we are going to have 3x squared. Whole y, very easy to multiply y. We are going to have 3x squared y, the what? The x all over the x. Am I right? True or false? Then plus, since we have two functions, whole x cubed, differentiate y. Any answer easy to multiply x cubed. If you differentiate y, we have 1 multiply x cubed is x cubed dy all over the x. The same thing applicable. We differentiate x, whole y cubed. We differentiate x. We have 1, use it to multiply y cubed. Here we are going to have y cubed dx all over the x. Then plus whole x, differentiate y cubed. We are going to have 3y squared. Easy to multiply x. We have 3xy squared. True or false? Dy all over the x. Then you differentiate 2 is what? 0. True or false? True or false? Look at the board. True or false? I'm seeing more of A class students here. I'm not seeing B and C class. More of A class students. B and C. Okay, I'm saying C9. But A are very serious students. I saw only C9 here. C8, C2, I'm saying only 8 students that are active here. C39. Okay, so let's proceed further to look at this idiot. So if you can see what I am saying, look at the board. This and this will go. This and this will go. So it means we'll have 3x squared y, then plus x raised to power 3 dy all over the x, then plus y cubed plus 3xy squared dy all over the x, isn't it? Amen? Amen. Okay? So we collect like terms. We take this to this side, take this to this side. True or false? So when we do that, the left hand side will now be x raised to the power of cube dy all over